Hello students, welcome back to the discussion of the chapter Electrochemistry. And in this module, we are going to discuss about the salt bridge and porous partition. So let us understand what the salt bridge exactly is. Now students, salt bridge here actually completes the circuit by facilitating the flow of ions. Precisely, it provides the internal connection in the galvanic cell. Alright, the external connection is provided by the metallic wires, but internal connection is provided by salt bridge. And how does it do it? By facilitating the flow of ions. It is precisely a U-shaped glass tube like this, and it is filled up with this semi-solid paste of some inert electrolytes like you have KCl, KNO3 or NH4Cl, etc. And to make it to a semi-solid paste, we are using here certain gelling agents like agar-agar gel or gelatin. Alright? And both the ends of the salt bridge are plugged with glass wool. So that was with respect to the salt bridge. One more thing you need to understand here, that the ions of the electrolytes, they do not react with the ions of the electrolytic solution. Neither they are getting oxidized nor they are getting reduced at the electrodes. Alright? So that was with respect to salt bridge. Now let us understand its function. So the function of salt bridge we'll be considering through one of the example, and that is the Daniell cell. So in the working of Daniell cell, we have seen that there is oxidation which is taking place at the zinc electrode and reduction taking place at the copper electrode, right? So we know that the transfer of electrons in a galvanic cell is from anode to cathode. So considering here the anode compartment consisting of zinc sulfate solution in which you have zinc electrode dipped, right? And obviously there is external connection through a metallic wire. So zinc undergoes oxidation and will enter the solution as zinc ions, isn't it? And it is going to leave behind these electrons. So precisely this oxidation of zinc all the time, okay, electrons will be transferred to the cathode and into the solution there will be excess of Zn2 plus ions. So there is a net positive charge around the anode, due to which the increase in concentration of cations is taking place, right? The positive charge around the anode will prevent the electrons to flow from it, okay? At the same time, what is happening at the copper electrode? You have a copper sulfate solution consisting of copper electrode, right? And now from anode, okay, the electrons are coming. So at cathode, what is happening? You have the reaction like Cu2 plus 2 electrons giving you Cu. Now these electrons are coming from anode, isn't it? So electrons will be getting into the copper electrode and copper ions will get reduced. So many such reactions multiple times will be taking place, right? So Cu2 plus ion concentration will keep on decreasing. At the same time, sulfate ion concentration is increasing, right? So at the cathode, there is increase in concentration of anions, that is negative charge, into the solution. And this negative charge around the cathode will prevent acceptance of the electrons from the anode. Now eventually what would happen? Reaction would stop and eventually no current will flow from it. Because in the zinc compartment you have Zn2 plus ions getting excess, and here in copper compartment you have copper ions, rather sulfate ions being in excess, right? Therefore, here you can clearly see during the working part zinc ions are in excess at the zinc compartment and sulfate ions are in excess at the copper compartment. So in order to maintain the electrical neutrality, you have salt bridge being introduced. So salt bridge consists of positive and negatively charged ions, right? So in the zinc compartment you have Cl minus ions moving. So Cl minus ions move to anode compartment, alright? At the same time you have K plus ions moving to cathode compartment in order to maintain the electrical neutrality. And because electrical neutrality will be restored, the current will keep on flowing, right? So thus the salt bridge prevents the accumulation of charges and maintains the flow of current. This is a role which is actually played by salt bridge in galvanic cell. Now, the same role is actually played by a porous partition. Okay? Now, this porous partition is not allowing the mixing of the solutions, but at the same time it allows the migration of ions through it. Okay? Now, during the functioning of the Daniell cell working part, you already now know that the concentration of sulfate ions in zinc compartment will be lesser as compared to sulfate ions concentration in copper compartment. And because of that, sulfate ions will migrate from copper compartment to zinc compartment. Alright? So precisely migration of ions, hence the internal connection is established and electrical neutrality will be maintained. So this is how we can allow the galvanic cell to function properly by using salt bridge or by using the porous partition. So I hope you have got a clear understanding of this particular module. Thank you all.